Okay, as always, 4 starters on the screen. Give it a couple minutes, see what you can do with these, and then the answers will be up. Okay, answers are here. The first question, you should have got that. If there's 3 to 7, we've got 10 boxes. 30 people divided by the 10 boxes means each box is worth 3. 3, 6, 9 boys all together. The second one, all the numbers are in the 3 times table, so we can divide by 3. They don't share any common factor other than 1. The bottom left, circles to triangles was 2 to 3. Triangles to rectangles was 2 to 5. I times the top row by 2, the bottom row by 3, which will give us a 6 in the middle, 4 to 6 to 15. And the final one, he gets £50 less. He also gets 5 boxes less. 5 boxes worth 50. Each box is worth 10. Marek gets £20. Okay. Pop your title and date in your book. And we are looking today at expressing ratios in the form 1 to n and using limiting factors. As always, make sure to pause whenever you need to, and make sure you take good notes of the examples before trying the questions. So, expressing in the form n to 1 and 1 to n. This comes up occasionally. You can also use it as a tool within ratio whenever it is useful to you. So, normally when we simplify ratio, we stick to whole numbers. So, for example, if we wanted to simplify 10 to 18, we'd simply divide by 2 because they're both even and get 5 to 9. However, if we wanted to, we could also express these things in the forms n to 1 or 1 to n. So for example, if I wanted to express 10 to 18 instead in the form 1 to n, I would divide by 10 because I have a 10 where I want the 1, which will give me 1 to 1.8. This has some practical applications that may well turn out to be useful for you in various ratio topics. For example, Charlie and Sam are strikers on a football team. Charlie has played 5 matches and scored 7 times, whilst Sam has played 12 matches and scored 18 times. Who scores the most goals per match? This is a sort of question that may well ask you to express your answers using the form 1 to n. So first of all, Charlie, who has played 5 and scored 7, if we express that in the form of 1 to n, we get for every 1 match played, Charlie will score 1.4 goals. Now obviously you can't score 1.4 goals, but that's his average. Meanwhile, Sam, who plays many more games and has scored more goals, well, if we again put it to a ratio of 1 match to goals, we need to divide by 12 this time. We get 1 at the front to 1.3 recurring. So in fact, in this case, Charlie is the more reliable striker. Charlie scores ever so slightly more goals than Sam does. Okay, here are our 4 questions. The first one wants you to express all of your answers in the form 1 to n. And in the second question, read it very carefully, it says your answer in n to 1. Pause it now, have a go, and then unpause for the answers. Okay, here are your answers. In the first one, I divided by 4 and got 1 to 2.5. The second, because I had a 5 at the front where I wanted the 1, I divided by 5, 1 to 0.6. The final one here, divided by 16 to get 1 to 18.75. The second half, you're going to do exactly the same thing, but instead you're dividing in order to get a 1 at the end. Divide both by 2.5 and get 3 to 1. Okay, the second part of this video is about limiting factor ratio. Limiting factor ratio is a topic that focuses on the idea that sometimes you may want to combine things in a certain way, but in order to maintain the ratio, you'll be limited by one of your resources. In this case, we're looking at green paint is being made by mixing blue and yellow in the ratio 5 to 3. Ben has 40 litres of blue paint. He has 21 litres of yellow paint. What is the maximum amount of green paint he can make? To do this, first, take our ratio. Blue to yellow is 5 to 3. And what we'll do first of all is say, well, what happens if I use all 40 litres of blue paint? Well, it'd give me 40 to something. To get from 5 to 40, I'm timesing by 8. And because this is ratio, I have to times the other side by 8. So 3 times 8 gives us 24. Now, unfortunately, I only have 21 litres. I can't do this because I don't have the ability to get 24 litres, and my green won't be quite the green I am looking for. So we'll try again, but this time we'll use all of the yellow paint. So I have the ratio 5 to 3 again. This time I have 21 litres of yellow paint, which means I'm timesing by 7. In which case, 5 times 7, because I have to do the same to both sides, gives me 35 litres. Well, I have 40 litres, I only need 35. I'll end up with a total of the 35 plus the 21, giving me 56 litres of paint. It may also ask you how much is left over. Well, 40 litres of blue paint, I use 35, 5 litres will be wasted. Right, here is another go. I want you to have a go on this one. You're mixing orange paint this time, red and yellow in the ratio 3 to 2. You have 15 litres of red, you have 20 litres of yellow. Pause it, have a go using your notes from the previous slides, and see what you come up with as an answer. When you unpause it, the answers will appear. Okay, if you have got an answer for this, you should have first of all taken your ratio and used all 15 litres of red paint. To get from 3 to 15, you're timesing by 5, so 2 times 5 would have been 10. You do have enough paint to do that, so that's 25 litres. Double check you can't do anything better by using all of the yellow paint. This time we're timesing by 10, or 3 times 10 is 30. I don't have enough. So the most paint I'm going to be able to make is 15 plus 10, 25 litres. Here is another example. This time we're mixing concrete using cement, sand and gravel in the ratio 1 to 3 to 5. Kieran wants to make 270 kilos of concrete. He has 15 kilos of cement, 100 of sand and 165 of gravel. Does he have enough to make the concrete mix? Well, we're going to do exactly what before, but this time we've got a ratio with 3 parts in it. So cement to sand to gravel is 1 to 3 to 5. Let's start with using all of my cement. If I use all of my cement, I'm timesing by 55. Okay, you're going to be using big numbers here. Get a calculator, make sure you make this easy on yourself. Well, if I'm timesing one part by 55, I have to times the other parts by 55, which is going to give me 165 kilos of sand. I don't have enough sand. And 275 kilos of gravel. I also don't have enough gravel. So unfortunately, this is a no-go. Right, we'll try again, but this time use 100 kilos of sand. Well, I'm going to be timesing by 33.3 recurring. So that gives me 100 kilos, which obviously I have enough of. But if I multiply out the other twos, while I have enough cement, I won't have enough gravel. The final one, I'm going to try this time to get all of my gravel, 165 kilos used. If you don't know, by the way, your multiplier, you can take what you have on the bottom here, divide it by the ratio, and it will give you this multiplier. Well, if I times both of those by 33, I get 33, 99, 165. I can do all of that. This represents the absolute most concrete I can make. Add those all up, it's 297. That's more than 270 kilos he wanted. He can make this. So for these, all we did exactly the same before. We wrote out a ratio. We picked one of the ingredients. We used all of it and used that to tell us our multiplier, and then worked out which version made the most without us running out of a supply, without us running out of a resource. Okay, same again. Now it is your turn. We have cement, sand and gravel again, mixed in the ratio 1 to 3 to 3. Nick wants to make 315 kilos and he has 35 kilos of cement, 150 kilos of sand, 130 of gravel. Pause it, use your notes, see what answer you get, and then unpause it for the final answer. Okay, so you should have, first of all, used all 35 kilos of cement, which would have given you 105 kilos of sand and gravel. You can do all three of those, which is good news, but it's not going to be enough to make the concrete mix, so we're going to try the other two variations. If we use all of the sand, unfortunately we'd need more cement and gravel, and if we use all of the gravel, unfortunately we're going to run out of cement. So the most that Nick can do is this version here, 245 kilos, which is unfortunately nowhere near enough the 315 that he needed, so he doesn't have enough. Now the reason, there are other ways of doing questions like this, the reason I like this version is because every time you do it, you'll not only be able to answer does he have enough materials, but quite often there's a second question, what's the most he could have made? Well, you've already solved that in advance, okay? That's why I like this method, okay? There are other ways, but this is my preferred because it always tells you what the maximum would have been. Right, here are three limiting factor ratios, one using the paints, one using the cement, sand and gravel, and actually another one using cement, sand and gravel. So give them a go. Read the question very carefully, make sure you don't mix anything up, and then when you unpause it, we can go through the answers. So for the first one, you should have, first of all, tried using all your red paint and realizing you didn't have enough yellow, then trying to use all your yellow and finding you needed 16 litres of red paint, which you have, so the best you could do for orange paint was 36 litres. James is making concrete. Well, here's what he has. That's the ratio he's using. The maximum he could have made, well, if he uses all of the cement, he's going to run out of sand and gravel. If he uses all of the sand, he has enough of both. And finally this one, he is going to run out of sand again. So the middle pile is our best bet, and adding those all up gives us 320 kilos of concrete. And finally, David is making up some concrete in the ratio 1:3. Does he have enough? Well, using the first version, using for all the cement, we're going to get an answer that unfortunately needs more sand and gravel. My apologies. The second, where we use all of the sand, you're multiplying by 47.5. I got that by doing 190 divided by 4. Well, that's going to give us those numbers, and we can do all of those. Now, it only wants to know if we have enough materials, so I can stop there. That's enough for me to do the answer. He can make 380, he only wanted 360, that's plenty. If you did do the other one, just if you want to check your numbers, well, he couldn't do that version sand, he's still on 380. Here is an exam style question, 2 marks for the first bit and then another mark for the part B. Builder mixes sand and cement in the ratio 4:1. Altogether he mixes 250 kilos. How much sand and cement does he use? Second part, cement is sold in 25 kilo bags. Work out the maximum amount of mix that the builder can make with 3 bags of cement using the ratio from the previous question. Give it a go, pause it, and then unpause it when you're done. Okay, if to check your answers, you should have got the first part. This is actually a ratio of sharing. If you were drawing boxes for these questions like this, you would have drawn 4 boxes and 1 box and split the 250 5 ways, telling you that each box is worth 50. So 200 kilos of sand, 50 kilos of cement. The second part, well, 3 bags is going to give you 75 kilos. There's your combination. Okay, so you had 4:1, you've got 75 kilos, so you're going to need 4 times 75, 300 kilos of sand. Mixing them together, 375 kilograms of concrete. And the final question, give this a go and then unpause it for the answers. Okay, this is a 4-mark question, and first of all, if you did your red to blue using all the reds, you'd have got 30 and 12, which unfortunately we can't do. So if we use all of the blue paint, we're going to get 22.5 litres of red paint used and 9 litres of blue paint. Add those together, 31.5 litres. Okay, that's everything today, so make sure that you submit your work to your teacher, and we'll see you tomorrow. Thank you.